Okay, so we're going to move on with Arhennius acids and bases. This is some new software I've got which might help us understand what's going on. This is Arhennius. He was a Swedish chemist, and he was one of the first people to come up with the idea of what an acid was and how to define it. And basically what he did was he took a simple idea of something like an acid that we use every day, like HCl. And what he did was he put the HCl into water. Now, as you know, most chemicals, what happens when you put them into water, they break down. So of course, HCl splits up into H plus ions and Cl minus ions. And that's when you put in something like hydrochloric acid. When you put in something like sulfuric acid, which is H2SO4, he found that that did exactly the same thing. So again, you were dropping H2SO4 into water. That was producing H plus ions, and it was producing SO4 dinegative ions. So this is one of these complex ions that you've got to learn. Now obviously the charges have to balance here, so we put a 2 in front of that, so there's 2 hydrogen ions. There is also another one, so if you look at something like phosphoric acid, which would be H3PO4, that will also break down, and that will give us this time again hydrogen ions plus PO4. Now this is a trinegative ion, so this has to be 3 over here. This idea of breaking down the HCl or the H2SO4, this is what's called dissociates. And this happens when you put an acid into water. And that's the important part, it has to go into water. So HCl dissociates doing this, H2SO4 dissociates, and it does that, and then phosphoric acid also dissociates. But the bit that we're interested in here really is this bit here. This is important for this particular part, but it's also important for the next definition that you've got to learn. So each one of these is hydrogen ions. So the way Arhennius defined an acid was, it's something which dissociates in water, giving out hydrogen ions. And that's the main definition. So Arhennius is acid. Arhennius. So the Arhennius acid is a substance which dissociates in water to produce hydrogen ions. And that's the Arhennius definition of an acid. Arhennius's acid. I'm just going to put this because there's a few bits and pieces that you need to know for this. The colours are nice. Right. So that's an Arhennius acid. Now, then we've got to look at what strong acids and strong bases are. And this is again within Arhennius's definition. So a strong acid is the first one that you've got to know. So a strong acid is an acid which dissociates almost completely Well, if you look up here, when you have hydrochloric acid, when you pour hydrochloric acid into water, you're not just getting one molecule of hydrochloric acid, you're getting millions and hundreds of millions of molecules of hydrochloric acid. So each one of those molecules is going to dissociate. However, whether it's a strong acid or a weak acid will dictate how many of these molecules will actually dissociate down. So for example, in a strong acid, an acid which dissociates almost completely, that means that the vast majority of its hundreds of millions of molecules will dissociate down. And again, we've got some examples of that. So obviously examples of a strong acid would be HCl, it would be H2SO4, which is your sulfuric acid, And then also you've got things like nitric acid, which would be HNO3. So this is nitric, sulfuric, and we've got hydrochloric. On the flip side of that, you then have a weak acid. So the weak acid has the opposite definition. And again, with a weak acid, you have an acid that only slightly dissociates in water to give H+ ions. Now again, if you wanted to make this maybe a little bit more accurate up here, an acid which dissociates almost completely, you would finish it off in there saying in water to give H+ ions. So that's the important bit, that's the full definition there. So acids that only slightly dissociate. So what sort of acids are they? Well, weak acids that we can think of would be something like this, would be CH3COOH. And this is ethanoic acid. Again, it's ethanoic acid because it's got 2 carbons. It's a COOH at the end. And this is more commonly known as vinegar. Now obviously vinegar is strong tasting acid, but in terms of chemistry it's actually quite a weak acid. There are other ones then, methanoic acid. This, which again is methanoic acid. Methanoic acid is the substance that's found in things like nettles and wasp stings and stuff like that. So again, a fairly weak acid. Arrhenius bases. And again, this is very similar to the acids, except this time you're dealing with a base. So what's involved in an Arrhenius base? So for example, let's say you have something like NaOH. So this is sodium hydroxide. And sodium hydroxide is quite a strong base. So what happens with sodium hydroxide? Again, when it's added into water, sodium hydroxide will break down its constituent parts, which is Na+, a sodium ion, plus OH-. And this one here is what's called a hydroxyl. Now you can just call this an OH- ion if you want. But again, the definition here for this is going to be the same as our acid. If you look at our acid up here, an Arrhenius acid is a substance which dissociates in water to produce H+ ions. The same thing happens for an Arrhenius base. An Arrhenius base is going to be the same thing, except it's not producing H+ ions, it's producing OH- ions or hydroxyl ions. So again, an Arrhenius base is a substance which dissociates in water to give OH- ions. And you'll find that in a lot of these examples you see in the book and questions and stuff like that, you'll actually see AQ written here beside the actual molecules. And the reason why AQ is written in beside the molecules in here is because they are in aqueous solution. In other words, they are in water. This only happens in water. Now obviously, if this is the definition of an Arrhenius base, substance which dissociates in water to give off OH-, that's just the general definition for a base. But then this has to be broken down into a strong base and a weak base. So in this one, we've got a strong base. So strong bases would be examples like NaOH. Would be something along the lines of, say, calcium hydroxide. So that's CaOH2, and magnesium hydroxide. So something like this would be used, NaOH would be used in things like oven cleaners, calcium hydroxide, magnesium hydroxide, and things like that would be found maybe in things like, you know, antacids and Rennies and all that sort of stuff. So there's your strong base and weak bases. The definitions still apply. So if your strong acid is an acid which dissociates almost completely in water to give H plus ions, the same thing happens with a base. I'm just going to copy and paste this one here. If you give me time, I'm getting used to this new software that I've got. So copy it, and we can bring it down here. And we can paste it in here as well. So in this particular example, it's not an acid anymore. And it doesn't give off H plus ions, but it is a base. So this is a base which dissociates almost completely in water to give OH minus ions. And again, that is for a strong base. You also have the same thing, except this time for a weak base. And again, we can change that too. So we're going to get rid of that. This is a base which dissociates. We could say almost, but it's better off if you say slightly. Slightly in water to give OH minus ions. So that's Arhennius acids and bases. Not perfect. There are still a couple of exceptions to the rule. But before you go on, something that you want to consider is a base in water. So we've been talking about a base in water. And that's called an alkali. Now, you've heard of alkali before, and often we interchange base and alkali. But all an alkali is a base that's mixed in water. The theory has a number of shortcomings. So, for example, Arhennius, the definition requires that water is always around. Other solvents, like methylbenzene and things like that, they're not considered. But it's a start, and it's picked up then further by the next section, which is Bronsted and Lowry, which is in a separate definition. So again, have a look through your revision books. This is just something to help explain it. If you have any questions, will you let me know in Google Classroom? And now that I have this software, I should be able to go through some examples and homework when we get a chance. Okay, thanks very much.